Welcome to my channel once again. This is Titration. In our previous lesson, we treated qualitative analysis and we explained what is meant by qualitative analysis. In today's topic, we are going to move to a new topic known as quantitative analysis. Quantitative analysis. What we mean by quantitative analysis, we measure the amount of substances. Not like qualitative analysis, we identify the ions that are present in salt, e.g. salt. So in this now, a simple word, quantity. When we talk about quantity, we talk about the amount of substance, the amount of substance. So quantitative analysis is to determine the amount of one substance that is known to us. We can use that known amount to identify the unknown. So by so doing, we must identify the amount of a certain substances. So a very good example, we can know the amount of certain substances by using a pipette. An apparatus in the lab known as pipette. In the lab, we have the 25 cm cube pipette or 20 cm cube pipette or 25 cm cube pipette. If you are able to pipette any of this solution, we can use this known volume of this substance to determine the other volume of the other substance that undergo reaction. So in this aspect, in quantitative analysis, we measure the amount. So we have two approaches to quantitative analysis. Two approaches. We talk about the volumetric analysis. We'll talk about the gravimetric analysis. In volumetric analysis, as the name implies, we measure the volume of a known substance by using it to compare the unknown. So by so doing, we can the gravimetric, this is a direct measurement of substance, direct measurement. So we use this to identify the volume. We use gravimetric analysis to determine a direct measurement of these substances. So we are going to dwell more on this volumetric aspect of quantitative analysis. A very good approach to volumetric analysis known as titration. So titration, we have different aspects of titration, but today we're going to talk about the acid-based titration, the acid-based titration, and we have a very common one known as redox titration. We said in acid-based titration, when we define neutralization reaction, we talk about a reaction between an acid and a base to give salt and water. In this aspect, this acid and base, they neutralize. When they come together, they neutralize each other to have an endpoint. So when we get to the aspect of this quantitative analysis, I will explain more. So a redox reaction, we're going to talk about redox titration. We must have, in this aspect, we must have an oxidizing agent, and reducing agent. So a very common indicator we can use here, we use a starch solution. So in this aspect, we're going to dwell more on this acid-based titration. And in this regard, if you don't know what is known as oxidizing agent and reducing agent, please check one of my videos. You'll see a comprehensive explanation on this oxidizing and reducing agent. So I'm going to talk more on this acid-based titration. A very important aspect of this titration is that we must know what is known as indicators. So indicator is just like what can tell us when a reaction have gone into completion. So in this aspect, we define indicators. They are organic dyes. That changes in pH. If, for instance, now if I should put an indicator in a solution, so this indicator the pH of such solution will determine the color of the indicator. So if there's any change, of this of the color, of the initial color to any of the color, we said the process of changing from one color to another, we say that point is known as neutralization point. So in a common terms, we call it what? Endpoint. So in this aspect, we have different types of indicator. So we have the methyl orange, the phenolphthalein, the methyl blue, the methyl red, and so on and so on. But in this regard, we're going to talk about the methyl orange. So we're going to talk about phenolphthalein. So in this now, methyl orange on acid and base, they have different color. Phenolphthalein on acid and base as well, it has a different color. So well, let's say we have base here, we have acid, we have here, let's say we have base as well, we have acid. So methyl orange on base, we have, it gives yellow, while in acid it gives red. Phenolphthalein base give pink. So in acid it gives colorless, always colorless. So if peradventure during titration, so if you should put it in, if you should add the indicator in base, it gives yellow. So if there's any change when as you are adding the unknown volume of the substance and there's a change of color from yellow to any other color, you can tell that the reaction has been completed. That is, there's a change in color. At that point, you can monitor your burette and know the volume that is used to neutralize such a known volume of the base. In this regard, in titration, the base, in acid-base titration, the base is always pipetted. We pipette the base. We pipette the base. As I've said before, the pipette in our lab, we have the 20 centimeter cube or 25 cm cube. So we already know the amount of the base. So we can use the amount of the base to determine the volume or the amount of the acid used in this regard. So in this aspect, what are the apparatus used in titration? What are the apparatus used in titration? A very good example, apparatus used in titration. Apparatus use apparatus. One, we use the beaker. We use a conical flask. So three, we have the pipette. We have the burette. So as and with this brief introduction, as we are carrying out the practical aspect of this course, I will display each of these apparatus. We are going to use we have to use resource stand. We want the major thing, beaker, conical flask. So these are the major apparatus we use. So in this aspect, we have, how do we arrange or how do we put this table for those of us that is writing WAEC next week, that is preparing for practical chemistry? So this video is specifically for you to understand the basic aspect of this titration. So reporting these values is very important in your examination, but because each of these, the table will carry 1 or up to 10 marks. So it is very proper for you to understand how to put this table for exam, under exam conditions. So how can we write this table, titration table? We are potting of titration table. So in this now, under WAEC is that the table carries a specific mark. For you to understand the table, please pay a very good attention. So in this now, there is a question will be given to you. You read the instruction on how the kind of indicator you are asked to use, the pipette you are asked to use, and make sure as you are writing in your school, you must ensure you know the volume of the pipette you are using as a student. If parameter your school is using 25 centimeter cube of pipette, you must ensure that it is boldly written at the top of your table so that the examiner will know the kind of pipette you use. So the first step in putting titration table, one of them is that you must name the indicator used. That is to say, if you are asked in the exam question, under the exam question, that you are to use methyl orange. That is to say, you at the top of your table, you must write methyl orange. You can say indicator methyl orange. So the next step, you must write boldly at the top as well, the pipette, the volume of the pipette. Pipette. You must tell the examiner the pipette you use in your center. So in this now, we are going to use 25 cm cube. 25 cm cube. In your score, if you are using 20, you must indicate here. So how do we put this titration table? It's very, very important, and it's very, very simple as well. So in this now, we're going to have a typical titration table. Let's have a typical titration table. A typical titration table. Yeah, we're going to, as I've said before, we said the first step, we must tell the indicator used. For instance, now at the top of it, you write indicator, said methyl orange. So we said pipette used, I'm going to use 25 cm cube. So the table goes this way. Table goes this way. So let's use it. Let's say we have this should be bigger. Let's have something like this. Let's say we have rough here. Rough, we have first, second, and let's have another column. We have the third titration. The third. So we say under this place, as you can see, this is a practical table on how you can arrange this in your exam condition. So in this now, we said here we're going to have the final burette reading. It's always in cm cube. And we talk about initial burette reading. So it's always in cm cube as well. We are going to have total volume of acid used. Total volume of acid used. So what is the essence of this rough? The essence of this rough is to fast track your work. That is to say, as you are titrating, for instance, they say you should place the acid on a burette. A burette is always held by a resource stand. So if you are asked, so you have a tap here that you can release. So you feed the acid. The acid is always placed in the burette. So we pipette the base, which is the B. We use the pipette. We place the conical flask here, for instance. So as you are releasing the essence of this rough is to fast track your work. So in this rough, you're not going to use it for your calculation. So in this aspect, if peradventure you are releasing after adding 25 cm cube of this, you added 2 drops of indicator and there's a color change. As you are adding this volume, you'll be notified, you take note of this color change. If there's any color change here, you stop adding this acid. So at that point, you must this burette is always graduated. It's always graduated. So in this aspect, you check the volume. For instance, now the volume here, it just ended here, that is around 24.00, for instance. So if for here now you say initial, you started, you must, okay, for instance, let's use in this aspect, I feed my burette to 0.00. Here, I'll write my initial burette rating is 0. And there are conditions for you to understand, is that there must be what? There must be 2, you must write this in 2 decimal points. In 2 decimal points. That is a simple law. So your answer must be in 2 decimal points. So if I should start from the origin, that is 0.00, and I heard here that I got 24.00. Yeah, I can say 24 minus this, I'm going to have 24.00. So what is the essence of this rough? The essence of this rough is that I will now, my first reading, I will now refill my burette to be 0.00. In this aspect, I can actually release this this my acid, if I should refill now, I can actually release this acid to at least to be 18. I can just automatically release the acid to 18. I believe that from 18 to 24, there might be color change. From there, I can be monitoring my what? My color change in my conical flask. So that is the essence of this rough. So that to fast track your work, instead of washing the color change from 0 down to 24, you can just release the burette, the liquid in the burette to 18 or 19. You believe that from 18 to 20 to 24, 25, there might be color change. From there, you can start monitoring the color change. So if, for instance, you refilled and you got like 23.90, for instance, you got here, this from minus Z, they're going to have 23.90. By so doing, if paraventure, you refilled all through, you got 23.80, 23.80. Yeah, you also refilled. You say you got 23.70. Yeah, 23.70 for instance. So in this regard, how can you have the average volume of acid used, in the sense that, yeah, you're not going to use this rough as a student. You must make reference to this first, second, and third titer value, always known as titer value. If paraventure, you notice that one of these value is higher, it's a bit higher than any of them. For instance, if for instance now we have something like 26.00 and we have here 23.80, 23.70. Since this one is a bit far from this value, you can just add this 2 divided by what? By 2. So if paraventure, you are using this 3 titer value, you are going to divide this value by what? By 3, by adding this 23.90, 23.80, 23.70 together, divided by what? By 3. So this is a typical titration table. So I'm going to introduce you to a major aspect of this titration table using WAEC marking scheme. Is that one of the important things is that, as I've said before, it must end. You must have 2 decimal point value, and the distance between this first, second, and third should not be more than 0.15, 0.20. So if for instance you are having here to be 24.00, yeah, you go like 30.00, yeah, you go like 25.00. There's an error in your titer value, since you might be having some issue with your dilution process and so on and so forth. So a very important aspect is that each of these titer values should not be more than, they should not be far from each other, around 0.15, 0.20. So how do you report this? If for instance as well, you're having something like 20.07, don't leave your titer value in this way. You can just approximate to what? You round this up, since it's above 5, you can say 20.10 is proper that way. So I'm going to introduce you to a very important aspect of this quantitative analysis, known as the calculation aspect of it. This is one of the aspects of titration. Let's use WAEC as a very good example. This is a very good aspect. How to plot the table, how to arrange your table in the examination, and so on and so forth, is a very simple aspect. But make sure this method, the indicator, the pipette you use in your centers, please write them down boldly at the top of what? Of your table. So we're going to talk about calculation aspect in quantitative analysis. Calculation aspect. What are the most aspects? We have 2 important formula we can use in manipulating 1 or 2 calculation in titration, using this titration as analysis. In this aspect, we have 2 important equations. We are going to have, we have one CA VA all over CB VB is equals to NA all over MB. So we say this CA is the concentration of acid. Concentration of what? Of acid. As CB also means concentration of base. So VA, volume of acid. That is the titer value you got at your table at the end of it. This is the volume of acid. So VB is what? Is your pipette value, which is, that is why you must know the volume of your pipette. Then we use, in this case, we use 25 cm cube. That is what? And the volume of base. Volume of base. So NA means mole ratio. Mole ratio of A, which is the acid. We said B, NB, we talk about mole ratio of base, of the base. So in this aspect, what are the conditions for us to use this equation during examination? One of the conditions is that, one, if the acid and base that is given to you, one of them, the concentration is given to us, concentration. If the concentration is given to us in mole per dm cube, we can use any of this equation. We can use this equation, I mean. If one of the concentration of the A or the B is given to us, we can actually use this formula to obtain the concentration of the other one that is not given to us. But if peradventure none of the concentration of the acid or that of the base is given to you, you cannot use this equation. So there's an equation that we introduce. It is given as mass concentration, known as mass conc, given a gram per dm cube, is equals to molarity, mole per dm cube times molar mass, gram per mole. So we define mass concentration as the amount of substance in gram that is what? That is in dm cube. We'll talk about the molarity. Is the mole of a substance that is dissolved in 1 dm cube as well. So we'll talk about the gram per mole is the molar mass of 1 mole of a substance. So in this aspect, if the concentration of the A or that of the B is not given to you, what will be given to you? The mole of one of them might be given to you, or the gram per dm cube must be given to you. If, for instance, now we say, if A, okay, say A is a solution of ACl and B contain 6.9 gram per dm cube of sodium hydroxide, for instance. Calculate gram per dm cube. Calculate mole per dm cube of A, for instance. Now, by so doing, we can use, see now, A is a solution of ACl and B contains 6.9 gram per dm cube of sodium hydroxide. Calculate the mole per dm cube of A. That is to say, each of the concentration of this A and that of the B is not given to us, but the mass concentration of this base is given to us. That is to say, we can use this mass concentration to manipulate by imputing in this formula, so that we can have the molarity of this B phase. So by so doing, if you are able to have the concentration of this B, you can now use Ca Va all over Cb Vb equals to Na all over Nb. So by so doing, I know the concentration of one. I can actually know the concentration of this by using this formula. So this is an important aspect of quantitative analysis. The calculation aspect of practical chemistry is the most important aspect of chemistry. So for you to become a sound student in science, you must know how to manipulate this aspect of chemistry so that you can work effectively in your lab as a student or as a professional. So in our next videos, we are going to talk about how to put 1 or 2 questions to just like in form of exam focus on what you are expected to say on Tuesday, being the 20th of this month, May 2025, so that you'll be acquainted with different way the questions will come through this method. So thank you for watching. Please, as you come across this video, do well to share this video. Thank you.